So let's understand pass-by mechanism in C, and I will ask certain questions. Let's say I have a function func increment. What it does is it increments a variable. So I pass it some argument, and what it does is it does arg plus plus. Okay. And let's say I have some code, maybe in main function I have some code, and what I have is int xyz equal to 10, and then I call the function func increment xyz, and then I print xyz. Okay, so I just print it, what is xyz. So now the important question to ask is, will xyz be 10 or will it be 11? So what do you think, what it will be?
10, sir. 10.
It will be 10 because xyz is passed
10,
by
10.
yeah because xyz is passed by value. In fact, C is completely passed by value. C has nothing else except pass by value. It doesn't understand anything else. C++ understands pass by reference, but C is totally pass by value. So what happens is that xyz arg is a copy of xyz. So I will like to draw a picture of what happens in the function called stack. That is very important for us to understand. So I should get the Jamboard. Okay, so let's see. I will draw that. Never mind. So some setup things. So here we are, and we like to visualize what is happening. Okay, so this is what is happening. All of us need to understand the concept of function call stack extremely clearly. Okay, and what is a function call we should understand. So function call stack looks something like this. Okay, so every function has a frame, function call frame. So we have main and some frame, and xyz takes the memory from this frame of main. Okay, and when we call func inc, so func inc or whatever, so arg is a copy of that, and arg is like this. So they may both have the value 10. When the function begins, func increment begins, arg has the value 10, and then you increment arg at line number 5, it becomes 11 also. Okay, but when func inc returns, this function call frame is destroyed. And what happens to xyz? Nothing happens to xyz, because whatever happened to be to a copy of xyz. Okay, so naturally it will not work. So now let's say my intention is that this should be incremented. Okay, so what can I do? First thing, actually ideally, if my source code is like this, ideally this should be a void, because I'm not using the return type. Okay, so that should be void. So if I want this argument to be incremented, one option I have is that I can change it to int, that okay, I will return incremented thing. So I will say return arg plus 1. But then somebody may say, no, I don't want the return mechanism being used. Keep the return void. I want this only. So the answer would be, okay, if that be the case, then right now let me say arg plus plus whatever. So then what we'll say is, okay, if you want xyz to change, then give me the address of xyz. You say and xyz. So what you are saying is that we will pass this address to the other function, and using that address directly it will change xyz, because it will have a pointer to xyz and it will directly change it. So what is the data type of address of x? It is int star. So you will say int star, and maybe you can say p underscore val, that's the value. Okay, and now you can say p underscore val. So actually ideally the cleanest code you will write is p underscore val star p underscore val plus plus. basically you are saying the value pointed at by p underscore val, you are incrementing that. So this code should work. This code should work. Okay. Some people they dislike to write parentheses. Somehow they become very happy when they write code like this, p underscore val plus plus. Okay, they don't write this code. And the moment people like me, when they see this code, then we wonder, okay, if that is the case, do I group like this, precedence, associativity, should I group like this, or should I am I incrementing and then doing a star, incrementing and doing a dereference? The star is basically dereference, right? Dereference means get the value. So then that confusion comes, and anytime that confusion comes, so the where is the shelter? The shelter is in the operator reference table. Okay, and we can see that. Let's see that also. So if you want to avoid this trouble of Google search and checking, and you want to avoid giving this trouble to other, you can just put brackets and then it's all good. But let me still take that trouble. So let's see that. So we have plus plus and star. So plus star and plus plus, those we need to compare. Okay, so we have star, that's the multiply. So star and plus plus, they are the same, they have the same precedence because they are at the precedence level 2. So star and plus plus have the same precedence. So now the associativity matters. Should I group left to right or right to left? And it says right to left. Okay, if that be the case, then it groups like this, and then that would be a shear error. So maybe you can experiment and you can experimentally convince yourself that this is a error, because this will group like this, which is like not doing anything. It is like, because the dereferencing thing is anyway discarded, p-val gets incremented, but p-val was a local thing. So but anyway, for now let's not get lost with that thing. Our focus is not there, so just ignore that. We come back to pass by value thing. We are simply writing clean code and we are incrementing that value. So how does it work? I mean, does it really work? Maybe there is something hazy in the brain, some picture is hazy. So what is the tool to clarity? The tool to clarity is a picture, whether on a paper or on some electronic thing. So let's draw a picture. Okay, so we just want to be clear. So what we are saying is that again the function, the program begins, and initially we have only main, and xyz is a tiny variable, integer, and address of this xyz, assume this address was 100 hypothetically. Okay, now when func increment began, a local variable was created, p underscore val. So from where the space of p underscore val comes, it comes from the stack only. Don't be in this thing that if it is a pointer it comes from the heap. No, nothing like that. If you have done malloc, calloc, realloc, they come from heap, but a pointer is just a tiny variable. It stores a address. So this p underscore val itself comes from the stack, and the content stored within this will be 0x100. So if the content is this, so we can pictorially draw that this p underscore val is actually pointing here. Okay, so this is how you will draw a picture when you are analyzing things. There may be many such situations where you want to kind of be clear what exactly is changing, what is the lifetime, will it live after the function returns, many things. So picture will make it clear. So if p underscore val is a pointer here, so star p underscore val is this value, and now we are incrementing this value, so it will become 11, and things will be all right. So this is pass by value and pass by reference thing. in C it is always passed by value. So for example, if you create a big struct, let's say you create a struct person detail, and maybe from his LKG UKG you are keeping all the data of the person, so this struct can be very huge. And if you write code like this, if you say okay, print sorry, that was whatever, print person data, some function, and now you are passing like this, you are saying struct person p, what to say, p, just like that. So, and maybe it doesn't return anything, void, and you have written some lot of printf or fprintf is to write into file. So this is a inefficient approach, because C is always passed by value. If you pass a structure is passed by value, so the entire structure will be copied. On the function called stack, you will see that big structure here, which is a copy of a big structure from the main. So that doesn't look good. So even in such cases, even if you don't want to change them, you can say okay, for sake of efficiency, just take the pointer. I don't want to change it, but change the take the pointer, don't take the structure. Now the moment you do that, some other people will say, and somebody may say that, oh, then via this it can change, and some programmer, if he or she accidentally changes, then what? So then people say that okay, I will say that it's a pointer to constant struct. Okay, so via this pointer I will not change. So sometimes you will have this approach used. You say const and you take a pointer. You are taking a pointer just because you wanted to avoid a big copy, but you don't want to confuse the people that maybe that this person has the right to modify the data. So you are declaring, you are asserting, even the compiler will check that via it is not modified. If via this PTR I'm trying to modify it, I will get a compilation error. So many times this is used, and but pointers are passed for primarily two purposes. One, you want to modify it. Second, it is very inefficient to copy. Just pass the pointer, it is efficient. Okay, so it is always passed by value, by the way, because when you pass a pointer, in a way pointer is passed by value. So C is always passed by value. And here when we said a function wants to return, basically wants to output the result of b plus c into this argument. So what you will do is you will say int star p underscore out maybe, and your code will be star p underscore out is equal to b plus c. So in that sense, such things are called output arguments, because the function is outputting certain thing via them. Okay, so function can or rather you can say return also, function is returning something via that out parameter. Okay, normally they can use the return data type also, but they can take pointers, and via those pointers they can modify stuff and they can give. So this will be the answer to that question, that have this output parameter and have these two input parameters, and this output parameter should be set to some of those two.